Statistics Modeling of Finance, Chapter 4, Inferential Statistics, page 19. Linear regression, example number 1. Linear regression, example number 1. The chart can give us a pretty good picture and a rough estimate. If you want to be more precise, you can apply the following regression formula. Capital Y over C equals A plus BX. Capital Y over C means the predicted value of the dependent variable. Low cap A means the constant. Low cap B means the coefficient or multiplier, independent variable. And capital X stands for the variable. So capital Y over C, the predicted value of the dependent variable, is what we are trying to find. What a property is worth. Low cap A, which means the constant, is the value where the regression line crosses the y-axis. In the scatter diagram on the previous page, you can't see that because I enlarged just a part of the graph so that it would be easier to see where the dots lay. If you looked at the whole scatter diagram and extended your trend line, you would see that it crosses the y-axis very close to 0. Look at the whole scatter diagram below and you will see what I mean. Shows the bottom part, the house size, the square feet in gross living area, starting at 900 square feet all the way up to 1,300 square feet. And then on the vertical side, it shows it starts at 100,000 and it goes all the way up to 160,000. Sale price versus size, square feet, gross living area. It says Y equals 123.31 X minus 9,440.9. R2 equals 0.8857. B is the coefficient that represents the slope of the line or amount of change per unit. From looking at the chart, we decided the change was about $123 per foot. That would be the B coefficient. Note, in the scatter graph created by Excel, you can add the equation and the R2 value as shown. In this case, the coefficient B is $123.31, and the value of the constant A is negative $9,440.90. Don't be confused, as sometimes A will be a positive number and sometimes it will be a negative number. Regression coefficient is defined as the coefficient calculated by the regression algorithm for the data supplied that, when multiplied by the value of the variable with which it is associated will predict for simple regression or help to predict for multiple regression the value of the dependent variable. For example, in the equation value equals $10,000 plus $5,000 multiplied the number of rooms. $5,000 is the regression coefficient for number of rooms. Regression line is defined as the line on a graph that represents the relationship defined by the regression coefficients. For example, the line from the relationship given in the definition of regression coefficient would cross the y-axis at the value $10,000 and would go up $5,000 for each movement of 1 to the right. This example illustrates one of the subtleties required in understanding regressions analysis. In fact, there is no line because the independent variable is not a continuous variable. But it is easier to talk about the relationship by pretending that the variable is continuous and represent the relationship by a line rather than the more nearly correct series of vertical bars on a bar chart. X is the amount of each variable. If we could assume those to be true values, not just approximations, what would be the value of a house with 1,132 square feet? Let's plug those numbers into the formula. Capital Y over low cap C equals $9,440.90 plus $123.31 multiplied by $1,132. Capital Y over C equals $9,441 plus $139,349. Capital Y over C equals $129,908. End of page.